All right, everybody, we just got it okay to start our planetarium show, so I want to put away our space trivia questions because now, folks, we're heading into the unknown. And welcome, everybody, to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just to let you know, I'm not just a voice coming out of the walls. I'm a person standing right behind you at the very top of the planetarium dome. Hey, good afternoon, everybody. Happy summer solstice, the longest day of the year. And don't hurt your necks. Look forward into the dome before you. Everything that you see in purple is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. And if you're looking for our projector system, it's hidden just below that purple glow. And folks, the show that we're going to be watching right now is my personal favorite. This one's called Tour of the Universe. And this show is completely live, so you're going to hear my voice for the next 30 minutes. And what we're going to be doing for the next 30 minutes, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe, as far as we humans can see. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things. But before we get started with the show, I have to go over some quick house rules just so that we're all on the same page and have a good time in here. First off, folks, there's no food or drinks allowed in. If you brought any snacks, make sure those are put away. We want to keep the theater nice and clean. We appreciate your help. Also, if you happen to have any cell phones, smartwatches, anything that produces really bright white light, now's a good time to put that away for the next 30 minutes, as these can be very distracting and takes away from the planetarium show experience. And also, folks, if you need to leave early, the exits are always going to be at the very top of the planetarium, so always make your way up the stairs to exit before, during, and after the show. If climbing the stairs is a challenge for you, the stairs are too steep, do not worry. Just remain seated. Once the show's over, we'll have a staff member escort you to a lower exit so you do not have to climb those steep stairs. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you have to do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. But with that being said, it looks like we're ready to go. So invite y'all to sit back, relax, and let's begin our tour of the universe. All right, folks, as I mentioned, we're going to be starting off pretty close to the Earth. We can see the city lights just down below, but we're starting off at this spacecraft right in front of us called the International Space Station, or the ISS for short. And folks, a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in articles and news, but I don't know what it is. Could you explain it for me? Well, of course, folks, the International Space Station is a research facility. Pretty much what that means, it's a laboratory that's orbiting around our planet Earth. And they conduct all different types of science experiments all the way up here, a little bit further from Earth, with less gravity. Some of the experiments they'll conduct are things like what happens when you try to grow plants in space. Do the roots grow in the same direction? Which way do they go with less gravity? Another one is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently as well? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compare and contrast the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have as much gravity constantly working down your muscles all the time. So if you plan to live in space for a long period of time, remember to exercise daily. And folks, the International Space Station looks huge on our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, you can also use the entire California Academy of Sciences, the museum we're sitting in. That's about how big it is. And also, folks, what's really incredible is that this thing is going incredibly fast. The International Space Station is traveling at a whopping 17,000 miles per hour, where it orbits around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, this looks really far away from our planet as well, but it's not too far. It's only about 225 miles above the surface of our world. 225 miles, that's not too bad. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. But to tell you the truth, folks, this is as far as we put humans into outer space nowadays, only 225 miles above the surface of our world. The reason why is because it's really expensive to travel into space. You got to buy yourself a rocket ship or build yourself one or pay to catch a ride on one. And then not only that, you have to account for all the rocket fuel. You got to be able to escape the Earth's gravity. And once you accomplish that, you have to account for all the food, water, all the air you're going to be breathing while you're out here in space. So the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop in our tour of the universe. So now we're going to see it slowly fade away to the city lights down below. And before we lose track of it, I want to add a nice little orbital path so we can see it as it slowly fades away. And it looks like we're hovering just above India right now, folks. And now we can see our entire planet Earth. And I want to let you know that the space program that I'm using right now is something that you can go home and download if you want to fly through space, just like how I'm doing. The space program that we're using in here is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace project, you'll come across a link where you can download this. Also, just to let you know, OpenSpace is not entirely finished. They're still working on it. It's in its beta phase. So if you come across any bugs or glitches, I'll point them out. Hopefully you can look past them. And also, OpenSpace uses a whole lot of processing power and information. So if you have an older computer, you may want something new or a gaming computer to give it a try to run this software. It pulls information from geo satellites. So use a newer one if you can. But if you're a person like me that doesn't want to download anything, you just want to fly through space, there's another great alternative called NASA's Eyes. Just like the human eyeball, type in NASA's Eyes, and you don't have to download anything, you can just fly through space, and it's so much fun. But in here, we're using OpenSpace. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions. That brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But the last time that we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars. But before we send humans to Mars, we got to figure out how we're going to be living out here in space. And the moon is the perfect stepping stone to figuring out the logistics of how we'll be doing that. And what's also really neat is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout the moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there, and we can melt that ice and pass electricity through it, and we can separate the oxygen and the hydrogen, and both that stuff's very valuable when you're really far from home. But again, we humans should make a return trip back to the moon in the next few years. Look out for any news about Artemis. And folks, when you look up at the moon here on Earth, sometimes the moon feels incredibly close. Feels like you can reach out your arms and touch it. But the moon's really far away. It's about 240,000 miles away from our planet. Whew, 240,000 miles from Earth. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles, it's kind of like using inches to describe the distances between cities because space is so big. Astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say bye-bye, moon. See you later. So cute. And now, folks, we're going to see the moon start to slowly fade away, just like how we saw earlier with the International Space Station. And before we lose track of it, just like how we saw earlier, I'm going to add some nice little planet trails so we can see where everything is in space. Because, again, space is so big. And folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace showing us the most accurate images and information available to us. So now we're going to see the moon and the Earth's orbit as they start to slowly fade away. And now the nearest star to us, the sun, should be coming into view. So here comes the sun. Do-do-do-do-do. And folks, the sun is also really far away. It's about 93 million miles away from the Earth. Whew, 93 million miles. In terms of speed of light, that's not too far away per se. It's only about 8.5 minutes at the speed of light. And again, this is a really cool concept to keep in mind because, again, the sun's 93 million miles away, 8.5 minutes for the sunlight to reach us here on Earth. Let's say the sun wants to turn off all of a sudden. We wouldn't know about it on Earth for 8.5 minutes because that last bit of sunlight will travel at 93 million miles at 8.5 minutes, and then all of a sudden the daytime on Earth would become nighttime. And again, this is such a cool concept because let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when you look at really far away objects in space, it's kind of like looking back in time in a sense, which is really cool. But now that we got a nice bird's eye perspective of our solar system, we're going to do a quick refresher. Right in the middle of our solar system, we have our sun, the biggest thing, our star. Closest planet to the sun, we have Mercury. Then we have Venus, Earth, that's us, and then Mars, the red planet. These are all the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past Mars, we have the asteroid belts. And this is what it would look like if to highlight all the asteroids. There's about 1 million of them or so, give or take. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest of them all, right here. Then we have Saturn, famous for its rings. And after them, we have our icy gas giants. We got Uranus, the funny one, and of course, Neptune. And of course, we can also add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen on the far right-hand side. And a lot of people don't realize that Pluto hangs out here in this way outer part of our planet called the Kuiper Belt. And a few of you are probably wondering to yourself, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. Yeah, that's a lot of stuff. So the Kuiper Belt's like a second asteroid belt way out here past the orbit of Neptune. And what you're mostly going to find are icy asteroids and short period comets that don't stray too far away from the sun. And what's really interesting is that in 2006, our telescope and technology greatly improved, so we were able to find a lot of stuff way out here in the Kuiper Belt region. We found more than 400 objects, and some of this stuff was bigger than Pluto. So we couldn't call all these things planets. There was just way too many of them. So all the astronomers across planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And folks, they came up with 3 criteria that day, and that was the day that Pluto went from being a planet to a dwarf planet. But that's the really cool thing about science, because as our technology improves, we're able to reclassify things and see how they fit better. So that's the really cool thing about science. It's constantly updating and changing. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be putting up on screen the many different spacecrafts we sent out in the 1970s to explore our solar system. Now on screen we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which flew by Pluto in 2015. All of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, It takes sunlight about 5 hours at the speed of light. 5 hours to get all the way to Pluto. Not too bad. But now, folks, we're going to leave our planetary scale behind because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense. It's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. Ooh, look at that. Alpha Centauri is just on our top left. You can see that star that's moving closest to us. So Alpha Centauri is on our top left right over here. We have our solar system right in the middle. And again, 4 years at the speed of light just to reach the next star system to us, folks. But that doesn't put into perspective of how long it would take us to travel that distance. Folks, if you were to get in a rocket ship today, left planet Earth, made your way over to Alpha Centauri, it's going to take you roughly about 8,500 years to make that trip. Whew! And that's just a one-way trip. But let's stop and consider whether humanity has made its presence known beyond our solar system, because now, folks, we're going to be stepping inside something called the radiosphere. And now we're inside something called the radiosphere. This represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into outer space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before the early 1930s, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year, so is anybody out there listening? And now, folks, I'm going to be adding these many markers onto the screen. These many markers indicate so many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us. 5,000 other worlds besides our own. And that 5,000 number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. In fact, if you look at the very top of our screen, you can see a whole bunch of exoplanets because we point our telescopes in that direction for about 10 years. So we found a whole bunch. As they continue to scan more and more of the night sky, they'll be finding exoplanets left and right. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, especially for us humans, well, we cannot answer that question quite yet. Pretty much new generations of telescopes are being developed, created right now, so we've got a few years before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light-year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, well, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system on the far left of our radiosphere. Let's say this one on the left. We find an alien civilization somewhere on the right-hand side. We find an alien civilization right over here. We shoot them a text message. We say, hey, we're humans. Are you friendly? Take 60 years to get to them. They listen in, answer back. Another 60 years just to get the reply text. Folks, that is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. But of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is constantly expanding, but it becomes weaker as it does. But I want to put away the exoplanet markers, and I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. All right, folks, we're now looking down at our Milky Way Galaxy, the galaxy we live in, and I've got to ask, can anybody see their house from here? And folks, our Milky Way Galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. And the Milky Way is so huge, we estimate that there's at least 300 billion stars in the galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way Galaxy, I want to show you what it looks like from the sideways view. You're going to notice that our Milky Way kind of looks like a big frisbee or a pancake in space. It's really flat. And this is important because when scientists and astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking to the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So again, keep that in mind. That's going to come important in just a little bit. We like to point our telescopes galactically north and south. But folks, the Milky Way Galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue expanding out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they create voids where there's very few galaxies or no galaxies at all. So we can see some nice clustering towards the center of our screen, towards the middle as well. We can see very few galaxies on our left-hand side or towards the top. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, this picture that we're looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tolley, who compiled this amazing representation over decades of time, along with other astronomers working aside him. So big shout out to Dr. Brent Tolley. But now, folks, we have automated systems that are mapping even the most distant galaxies, because now we're about to view the large-scale structure of the universe. And remember, folks, every single point of light that you're seeing that's not a star, that's an individual galaxy. And by the way, the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big flat spiral disk of our Milky Way galaxy? Well, if you were to line up our Milky Way, it would line up just like so, right up and down. Again, we like to point our telescopes galactically north and south. But astronomers still want to make sure that there was galaxies through the plane of our Milky Way, so we have this purple survey. You'll notice that we're still able to find them, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill in all these gaps that haven't been filled in yet, so it's just a matter of time. But looks like we're running close out of time on our tour of the universe, folks, so we got to continue pressing on, because now we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are going to be represented by orange dots on either side of the large-scale structure of the universe. And quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years apart, or light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe, and what we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. All evidence indicates that the universe that we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. And this is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image where the light echoes of the Big Bang are color-coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny and vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is at the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. That's going to be back towards home, towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. This looks like a good spot. And let's make a return trip back to planet Earth, everybody. All right, folks, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, everybody, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope. And there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way Galaxy. We're heading straight for that radiosphere. And now we're making our way back to our star system, our solar system, our little neighborhood in the vastness of space. And now we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto and the Kuiper Belt region, and making our way back to the third rock to the sun, our home world, planet Earth. All the people that we know, love, ever learned about in history, all lived on this one planet. And now, folks, we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, if you want to share this show with a friend or family member that wasn't able to come and visit, you can always check out this exact show on the Morrison Planetarium Facebook page or the California Academy of Sciences YouTube page. So you can share this with anybody that you like if they missed out. But hey, we made it back home safe and sound just in time for dinner time. And that's all the time we have today, folks. Thanks for stopping by, and I hope you all have a great rest of your night.